Welcome back, folks. In today's class, we'll talk about the projectile motion. Projectile motion. So, in lecture number 3 and 4, we talked about the object moving in the vertically upward direction and also the object moving in the forward direction. These are the two displacement we talked about. If I combine this vertically upward motion and the horizontal motion together, then I'm going to get the 2D motion, which is called as a projectile motion. So it will look like something like an inverted U. So that's a projectile motion. So in this case, I can see the object is not only moving in the forward direction, but also moving in the upward direction, forward direction, upward. At this point, when the object reaches at the maximum height, at this point, object is only moving in the forward direction. There is no vertical height because it has already reached to its maximum height. Now, down here, the object is moving down and forward to, down and forward to. Now, before I jump into solving some problems on the projectile motion, I'll talk about certain rules which we need to take care of. So first rule is if the object, let's say this is a cliff, and the object is thrown from a cliff, and the object lands at the same height from where it was thrown, then the delta dy, displacement in the vertical direction, will be equal to 0. Horizontal displacement won't be 0 in this case. There will be a horizontal displacement that's called range. So horizontal displacement delta dx is equal to range. And the height attained, this is the dy displacement. That's delta dy or max height from the reference point. Now, another rule which we're gonna talk about, if you throw an object from a height and then you catches at the same height on the other end, then the time taken by that projectile to reach on top will be equal to the time taken by the projectile to land onto the ground. Keeping this thing in the mind that the object is landing at the same height, only then that's gonna apply. If the object is thrown from a cliff, so a person throws an object from the cliff and it lands onto the ground, which is, I can clearly see in the diagram, not at the same height. In that scenario, time taken to land on the ground will not be equal to the time taken to reach to time taken by the object to reach on top. So whatever time, let's say it takes t1 time, so this time is, let's say, t2. So t1 is not equal to t2, whereas in the previous case, this time t1 is equal to t2. And then another thing we're going to talk about, that the friction loss is 0 in case of a projectile motion. That's what we assume. So if the friction loss is 0, then I will take the displacement equation delta dx horizontal. I'm going to apply this equation in the horizontal direction. Delta dx is equal to vi y, not y because we are in the x direction, vix times time plus half at square. So friction, what kind of a friction is there when you throw the projectile in air? There is only air friction. So because the friction due to air we consider as very negligible, so acceleration will be 0. Well, in this case, I should say the deceleration, because air is causing a resistance. So there is no deceleration, almost negligible. So we'll cancel this part, and then we will come up with the formula delta dx is equal to vix times time, and delta dx I've already talked about. This is also called range, equal to vix times time. Another thing we need to take care of is, while solving the question, we need to pay attention to the wording of the question. If it says the thing, something is dropped or a projectile is dropped from a certain height, dropped means even, even though if you are throwing some horizontal velocity, the viy will be equal to 0. So dropped or throwing something with the horizontal velocity means that viy, initial velocity in y direction will be equal to 0. So if you can recall the five equations, those five equations were acceleration equal to v final minus v initial divided by time. Another equation was vi, uh, uh, I guess v initial times time plus half at square. This was another equation, and another equation was v final times time minus half at square, and then another equation was v final. These two were first of all delta d equal to, and this equation v final square equal to v initial square plus 2a delta d, and then the final equation was vi plus v final upon 2 times time. This was equal to delta d. So these five equations we've learned, and then we also learned how to apply them in the vertical direction. So that's what we're going to do. We're not only going to apply these in the horizontal direction, we're going to apply them in the vertical direction, and then we're going to combine it. So just a recall, when we are applying these equations in the vertical direction, then at that time we replace the a with the g. So if I see the case, delta dy, it will be equal to vi times time plus half at square. G, a will replace with g now. Now when, because I'm applying in the y direction, so I have to mention initial velocity in y direction, and g, as a is replaced with g, it automatically means that we are in the y direction. And down here, while let's say apply in the horizontal direction, then that this equation will change to delta dx is equal to vix times time plus half at square. But as I said, there are no frictional losses. We are talking about the projectile, which is covering the displacement in air and also in the forward direction. So this portion becomes 0. So delta dx value will be equal to vix times time. Now, so I'll take another example of this formula. This formula, if I have to apply in horizontal direction, so v final x equal to v initial x plus 2a delta d, and this is final square, initial square, and then because there is no horizontal displacement, and then we can also say that in horizontal direction, final velocity is equal to initial velocity. V final is equal to initial velocity. So if you are throwing, so what does that mean? Let's say if I throw a projectile from here at a velocity of 20 meters per second at an angle of 30 degrees with respect to horizontal. So this is a 2D vector. This velocity vector is a 2D vector. So I first of all, I have to find the component of this vector in the horizontal and the vertical direction. So horizontal component will be equal to v cos of 30 degrees, and the vertical component value will be equal to v sine of 30 degrees. And v sine of 30 degrees, which means 20 sine of 30, which gonna give you 10. And then down here, this is 20 cos of 30. Cos 30 is 0.866, and if I'm not mistaken, it's gonna give you something like 17.3. So I don't have my calculator with me, so I'm just giving you the rough calculations down here just to make you understand how this is gonna work. Now, what's going to happen in this case is, if I'm trying to find, let's say I'm trying to find the range, and range means what? Range is the horizontal distance. This is range. First of all, as I proved here, final velocity will be equal to initial velocity. So this velocity of 17.3, horizontal velocity VIX, this velocity will not change. Horizontal velocity will remain same throughout the process. So I'll draw it like this. This will remain as 17.3, 17.3 throughout the journey. Only velocity which is going to change is the vertical component. At the top, VIY is equal to 0, but there will be some vertical velocity which will be downward. VIY, there will be some VIY, there will be some VIY. So that's how it's gonna work out. So hopefully you understand what's the gist of initial velocity equal to final velocity in the horizontal direction. Now let's go back to this example which we started with. So if the horizontal velocity is this much, 17.3 meters per second, and I were to find out, let's say, total well, I will say the range, as we were looking for. The range is what we're looking for. The total time taken for by the projectile from here down here, let's say, is 3 seconds. Time is equal to 3 seconds. So how I'm going to find it? So I will write the formula as delta dx is equal to Vix times time. Notice I've mentioned it Vix. So Vix means I have to take the horizontal component of the velocity, which is 17.3. So delta dx is equal to 17.3 multiplied by 3. So again, as I said, I don't have my calculator with me, so you can do the calculation. This should come out to be 51 point something, 51.9 if I use these numbers, if my calculations are correct. So delta dx is equal to 51.9 meters. So that is the distance covered in the horizontal direction. Now, at the same time, if I were to, if the examiner has asked us to find out the maximum height attained by the projectile, how are you going to find the maximum height? So that will be equal to delta dy is equal to Vix times Viy, shall I say, Viy times time plus half at square, or a will replace with g, now gt square. This is the formula you're going to use. And then in this one, initial velocity, you will have to replace, you cannot use, first of all, you cannot use this, you have to replace it with the y component of this velocity vector. This is 20 and the y component is 10, 20 sine of 30 degrees. So we'll only use the y component, which is 10 times 3 plus half times g value is negative 9.81 times t square, which is 3 square. And then from here, we can calculate delta dy, which is equal to, well, uh, here I kind of made a mistake. This is the total time taken by the projectile to from starting from here to land on the ground. So I cannot use this time down here because that's the total time, and I'm trying to find the maximum height attained by the projectile. So if you are given that the projectile lands at the same height, you can directly half the time. That is one way of doing the question. Another way of doing the question is you can directly put in the time as 1.5 here, 1.5, and get the answer. Notice I just wanted to tell you this is a random number which I'm taking right now just to make you understand. Okay, and then you can put in down here also 1.5. Another way of solving this question is, let's say this time is not given to you, 3 seconds is not given, we don't have this time. How are we going to solve this question? We will again look into what's given to us. Vix is given to me, which is Viy, sorry, because we are talking about the height. So everything we'll shift our focus towards the vertical direction, and every parameter which we're going to take will be in the y direction. So Viy is equal to 10 meters per second, which is the object is moving up, so I'll keep it as positive. And g value is negative 9.81 meters per second square, and velocity on top. So you can, this can be a tricky situation. You can say that, okay, the object is still moving with certain velocity, which is 17.3 meters per second, but that is the horizontal velocity. What is the vertical velocity on top? Vertical velocity on top will be equal to 0. So that's why it is on top. Otherwise, if there is a vertical velocity, either upward or downward, when we cannot call it as if the object is on top. So now the we can also find the height by using these parameters, because final uh, v final y is equal to 0. Again, don't confuse yourself. Only in horizontal direction, Vix is equal to v final x. That's only in horizontal direction. In vertical direction, they won't be equal. And delta D is equal to Vi. We wanted to find the height, so we can use the equation. Which equation I can use? I think I can use the equation V final square equal to V initial square plus 2A delta D. And because this is in vertical direction, so A will be replaced with G, and this is Y, and dy. So final velocity is 0 on top, and then VIY is equal to 10 square plus 2 times 9.81. This is a negative. Always G value is negative in the kinematics. Multiply by delta dy, which is what we are looking for, delta dy. And then this 10 square will go on the other side. That's going to become 100 with a negative sign because we are moving it on the other side. Remember this, I'll tell you, this is where students make mistake. Negative 10 square, this negative is outside the bracket, so we will keep this negative with the question. If it was inside, then we would have eliminated it. Right now, this negative is outside the bracket. So negative 100, which is equal to, this is 19.6 times delta dy, and then dividing both sides by negative 19.6 delta dy. 19.6 cancels out, negative 19.6, and that's going to give you vertical height. Delta dy is approximately 5.1. Again, I don't have the calculator. You can do the calculation and get the accurate number, this much meters. So hopefully that tells you how you're going to approach the projectile motion questions. And I think that's it for this class. I'll see you with another video lecture on the projectile motion. Till then, goodbye.